Okay, this video is doing trig application problems finding angles. Okay, previously we did application problems where we just found sides, but today we're finding angles. So first I'm going to revisit our conversation we had about angles of elevation. If you remember, angles of elevation are always angles. Angles of elevation are always looking up. So if this is a straight line and the ground, this is the ground looking up, angle with the ground is considered an angle of elevation. Okay, that is my angle of elevation. Angle of depression means there's something up high, and from this line of sight looking down, that is the angle of depression. And recall that if you make your right triangle, that angle of depression doesn't fall within that right triangle. Its alternate interior angle is the same. So this is theta, just like this one is theta. These are the same measurements. Okay? So it just depends on how you build your right triangle as to where that angle theta is. But you have to remember that wherever that line of sight is, the depression, that's always looking down. Elevation's looking up. Okay? So today we're going to be finding those angles. It's very important that you draw pictures and understand the concept of what's happening. Alright, so look at this example. You're standing at the top of a gorge. The bridge across the gorge is 700 feet long. The sides of the gorge are 1350 feet high. Find the angle of depression from the bridge to the bottom of the gorge. Okay, a gorge is like a canyon, right? Kind of like a big old canyon, right? And here's my right triangle. This is the canyon. It says the sides of the gorge are 1350 feet high, so that's the height. Angle of depression from the bridge, here's the bridge, right, to the bottom, looking down to the bottom, this angle right here is what we need to find, right? The bridge across is 700 feet, so that means the base of it is 700 feet also. So if this is my right triangle, if this is angle theta here, then my angle theta sits right here. Now, relative to angle theta, what two sides do I have? I have the opposite and I have an adjacent side. So if you remember SOHCAHTOA, which ratio uses opposite and adjacent? Well, that's the tangent ratio. So what I'm going to say is the tangent of theta, that's the unknown angle, equals the opposite side over the adjacent side. And then I'm going to use the inverse tangent function. All right. So I will find out that when I type it in, inverse tangent of 1350 over 700 I find out that the angle theta is 62.59 degrees. Okay, you have to be in degree mode for this to work again, but inverse tangent is just second and tangent, and you type in that fraction. Let's try another one. You are flying a kite and you've let out a string of 200 feet. The kite is 151 feet in the air. What's the kite's angle of elevation with the ground? Okay, that's your clue. So here's your kite. Kite's up in the air, right? Here's the kite. Angle of elevation is this angle right here. That's what I need to find. So what does it say? 200 feet of string. This is the string. And we know it's 151 feet in the air. That's the drawing I'm looking for. Okay, you don't have to draw the kite, but the right triangle for sure. To find the angle, I need to know what ratios I need to use. Well, this is my opposite side. This is the hypotenuse. So remember SOHCAHTOA. Which one uses opposite and hypotenuse? Well, the sine does. So I would say the sine of theta equals opposite, which is 151, over the hypotenuse. But I have to do the inverse sine. So to find theta, I'm going to do, on my calculator, I'm going to hit second sine and 151 divided by 200. And I find out that that angle is 49.03 degrees. All right, so a cellular telephone tower is 150 feet tall. We know it's going to be a right triangle because that's what we're doing. What's the angle of depression from the top of the tower to the cell phone user? That's down here. Who's 2,439 feet away from the base of the tower. So that's down here. So I'm looking for this angle right here, theta, looking down. Remember that theta is outside my triangle, but I can put it inside in the opposite corner. Okay? Now, relative to this angle, I have the opposite side and I have an adjacent side. So if you remember SOHCAHTOA, okay, which one uses opposite and adjacent? Well, that's the tangent. So I say the tangent of theta equals the opposite over the adjacent side. Inverse tangent on both sides. That cancels on the left, so I have left with theta is equal to the inverse tangent of whatever I get here, 150 over 2439. So I type this in my calculator. And I get an angle of 3.52 degrees. It's a very small, baby little angle. All right, I want you to try this one. Set it up, draw the picture, write the equation. If you don't have a calculator, get as far as you can until you get to class, and we'll see how you did.